Suite à nos premières investigations dans la recherche,
In the course of our scientific investigations, we realized early on that we needed an underlying concept. This initiated the Advanced Research program. The developments we implemented included the escape wheel in oxidized silicon in 2005, the Spiromax balance spring followed in 2006, and in 2008, the Pulsomax escapement in silicon, which currently beats in 2 calibers. In 2011, we created the butterfly-shaped silicon Gyromax balance. In our research work with universities, the CSEM and the EPFL, the Swiss Federal Institute of Technology, we felt that it would be appropriate to establish a dedicated chair. So horology has arrived in academia and the EPFL. Thanks to this chair, we now have about 15 engineers who deliver very specific innovations for our products.
Des innovations spécifiques à nos produits.
The goal of the Spiromax was to attain concentric breathing like the Breguet hairsprings to improve the rate accuracy of our watches. That was the first step in 2006, our point of departure for a second terminal curve at the center to reduce rate deviations in vertical positions. The rate remains constant regardless of the orientation in which the watch is worn. The rate accuracy of the current collection ranges between -3 and +2 seconds per day. In the Advanced Research series, we've improved it to -1 and +2 seconds, the result of 10 years of work for this balance spring. For a temperature-insensitive oscillator, we needed a self-compensating spring material. To this end, we developed Silinvar in 2005 with 2 other manufacturers. It is a composite of silicon oxide on a silicon substrate used for thermally compensated hairsprings. In 2012, Patek Philippe set up a hairspring production facility in Neuchâtel. It is a competence center for photolithography, deep reactive iron etching, and oxidation for complete Patek Philippe balance springs. Developed in 2006, the Spiromax is protected by 9 patents, including the integrated attachments at the stud and collet, and features a special geometry that improves the isochronism of our watches. The compliant mechanism is intended to replace articulations with flexible systems. We no longer have an arbor that rotates in bearings. We have a leaf spring that bends and performs a rotation or a linear motion. The big advantage, it requires no lubrication. There is no mechanical play, so it's more reliable and precise. The concept and production are more complex, but for the owner, the product is more dependable. We can build smaller components, an important aspect for Patek Philippe in creating slender timepieces. Graceful watches are the result. We increase functional precision and long-term functional integrity because we have no play and no lubrication points. Designing such parts requires state-of-the-art computer simulation. We need to simulate motion and take the material's stress limits into account. The parts must be impact resistant and work reliably even when exposed to shocks. Challenging developments of this kind are possible only with computer simulation. We have to simulate everything with materials and extremely small parts. Important, all these parts are made of conventional materials, normal watchmaking steel and conventional milling with CNC machines. These parts are also hand-finished. This is a big technical challenge for very small parts. Their finissage complies with the directives of the Patek Philippe seal. This requires considerable technological modifications.